Hello everyone, and welcome to the first in my series on Kenneth Waltz's theory of international politics. My name is Charles Kirchhofer. I'm a PhD candidate at King's College London. Finishing up my PhD, should be done this autumn. And I'm going to guide you over the next few weeks, any of you who last that long, through Kenneth Waltz's book Theory of International Politics. Now, you may be wondering why I'm doing this and why you should read the book. Well, the book was really a revelation for me. When I read it, I felt I understood so much better what causes conflict in the international system. And it also allows you to really think more systemically. I think it'll improve your writing and improve your ability to think as well if you stick through it. Yeah, and it's I'm doing the series because the book is very difficult to read. So I think I had trouble with it as a master's student, and most of you are, I imagine, are bachelor students listening to this. So it is not an easy thing to get through. That's why I'm providing the assistance. Why am I doing it? Because I like it. Because I felt that my students at King's College London who weren't getting an opportunity to read Waltz should. And I'm also doing it because I think it will give me practice teaching and help improve my skills, so there are some selfish reasons for me to do it as well. Before we get started, we should talk about a couple of key terms, and those are induction and deduction. These are words you probably have heard many times before, and many of you may already know what they mean, but for those of you who don't, induction is just reasoning that starts from the bottom up. Individual observations and then creates a general rule from them. An example of this is all humans thus far encountered have been mortal. We therefore assume that all humans are mortal. So from the individual, we've encountered lots of mortal humans, to the general, all humans are mortal. It could work with a percentage too. 95% are mortal. It's an if-then sort of statement. And deductive reasoning takes that and flips it around and takes something already discovered or believed to be true and goes downwards. So all humans are mortal. You take that big general rule and you say person A is human, therefore person A is mortal. That's all there is to it. That's induction versus deduction. Important in the first chapter to keep those two in your mind and know what they mean. Okay, let's get to the actual book, and I do recommend listening to this presentation and going along in the book side by side, because I'll cover them in order, and it might be easier for you to do it bit by bit, so the reading as you go through it, so constantly pausing the video. First thing I'd like to note out is look at what Waltz sets out as his own aims for the book, and you should judge the book at the end according to those aims. And that's how you should judge any book. That's how your instructors will be judging you. That's how I judge my students. What do they set out to do, and how successful are they? How successful you are will depend on what sorts of goals you set for yourself. So be careful. If you set really complex, difficult goals, you're almost certain to fail. If you set really easy goals, you may succeed, but it might not have been ambitious enough. So spend a lot of time thinking about that. As for Waltz's goals, they're very ambitious. Have a look at them. I mean, he's trying to remake the whole way that we view the world, and I think he's quite successful, which is quite amazing, and it's a reason why you read the book and a reason why he's so influential decades after he wrote this. You'll notice in the book that he talks a lot about other sorts of theories and theorists who most of us will not have heard of anymore. We still hear about Waltz, we don't hear about any of these others, and that's because he's really good. Okay, big difference, big thing he starts talking about at the beginning is laws and law-like statements, and he differentiates between those and theories and hypotheses. A law-like statement is simply if A, then B, with a probability of X. It's a description of a relationship, not a theory and not an explanation. Theories explain things. Hypotheses are things that can be tested. But laws and law-like statements simply give a description. A law, for example, would tell you how quickly an object accelerates at 1 g of gravity, for example. It doesn't tell you why it does it, but it tells you that it happens. That's a law or a law-like statement. It doesn't explain. That's really important, and you'll see why coming up. Okay, the next thing is we have to contrast laws with theories. It's really important that you understand this very specific usage of theory that Waltz is using here. It's definitely not in the colloquial sense of, oh, I have a theory about that, meaning just this is how I think it happens. but most academics would not use it in that way. Another way that you may be coming across in reading is a collection of laws on a particular topic is a theory. It's just a bunch of different laws, descriptive relationships between things, and that's called a theory. Waltz explains that he thinks that's a waste of the use of the word theory, and that theory is something altogether different from a law, and this is a philosophy of science definition of a theory, which is that it's an explanation of the phenomena or relationships described by laws or law-like statements. So a theory explains something, whereas a law describes something. That's it. Sounds very simple, but it's really important that you keep those things apart, and you'll see why again. Now, as Waltz says here, no matter how securely we nail a description down with numbers, we still have not explained what we have described. Again, we're just describing. We're saying that stuff happens, but we still don't understand why. And this is what Waltz refers to here as the inductivist illusion on the top of page 4. And it's the idea that we can arrive at the truth or an explanation just by observing more and gathering more and more data. But as I've pointed out, data alone don't tell us anything unless we have a theory, an explanation on how to interpret it. Again, we're just saying that stuff happens and we see that they happen. We may see that there are relationships between things. We may see that when this happens, this very often happens again. We may see that there's a relationship between thunder and lightning, that they both happen. But until we have a theory about how lightning could create thunder, for example, until we understand the differences between the speed of sound and speed of light, do we understand the distance between them, then we don't understand anything actually. We just observe that they tend to come together, but at different distances apart. We have no idea how this explains anything. An example from economics that I'm putting forward is that 0% interest rate should spark inflation. But this is no longer true in the current environment. If you look around, a lot of central banks throughout the world have their interest rate set at 0, and yet inflation is very low and even negative in many places. And looking at the data and correlations it previously held will not tell you why. Throughout history, 0% interest rates, or many parts of history, would lead to inflation, and suddenly there isn't inflation. Without economic theory, we wouldn't understand why that is. So just saying that things are related is not enough. That's the inductivist illusion. If we describe and describe and observe, we will not get any closer to understanding anything. Another way to say that is what Heinrich Hertz said, and it's a quote on page 5, "That which is derived from experience can again be annulled by experience." An example often used for that is that if you didn't know any better, you might think that all swans are white, and you could have a law that says all swans are white, until one day you saw a black swan. And then suddenly your law would be invalidated, and you wouldn't understand how in the world that black swan got there. And I'll add, you won't know why without a theory that tells you what you're experiencing and how it relates to other experiences. You need to understand something about genetics to understand why there'd be a black swan, and you need to understand something about supply and demand and the price effect. The price mechanism in order to understand 0% interest rates and inflation and things like that. You'd have to understand ideas of excess supply or not enough demand and things like that, and where those things could come from in the current environment to understand deflation and low interest rates coming together. You need theory to understand what's happening. Now at this point I can imagine some of you saying, okay, we get it, we need theories. Why are you going on about this? The reason that Waltz and I are going on about this is because many people who claim to be presenting theories are actually presenting descriptions of things, which are laws or law-like statements, and he will show this later. And it's also to go against the inductivist illusion, particularly in the 1960s, but it continues today. There's this big push for quantitative. Yeah, show your numbers, show your data, and all that. And Waltz was pushing back against this, saying, yes, numbers and data are great, and they can help us understand things, they can help us describe things, but they don't by themselves help us explain anything. We may need the data before we can even start to come up with a theory, but data alone are not enough. That's the point. Okay, and that brings us on to theoretical notions. He talks here about how one comes up with theoretical notions and says that they can only be invented and not discovered. And I see there's a mistake on my slide here. There's no answer to that. How do you come up with a theoretical notion? How do you figure these things out? You just need a eureka moment. And this can occur after induction has delivered you with a load of correlations and you propose a way to simplify some of them. So you may, from all of those masses of data which we've said don't explain anything, you may, looking at the data, come up with an explanation of your own. Okay, so what is a theoretical notion? A theoretical notion is not the entire theory, by the way. A theoretical notion is a simplification. It's one element of a theory. And a common one that you may have from, or you may be familiar with from math or calculus or physics, if you've done that previously, is Newton's idea of point mass. Newton knew that mass does not concentrate at a singular point, but that's not the point. Viewing it as if it were true makes calculations easier and no less accurate. Okay? His assumption of point mass, like all theoretical notions, is not an assertion of truth. It can't be proved wrong because it's not meant to be true in the first place. So pretending that mass concentrates at a point makes it much easier to do mathematical calculations, and scientists use this for launching satellites and all kinds of complex things like that. And you pretend that mass concentrates at a point so that you can do your calculations more easily, even though you know that's not true. All right, and the same thing is true when we view states as actors in the international system. We all know that states don't think or act. We all know that states themselves are theoretical notions. They're a theoretical construct. There's nothing about truth in them. You don't have to explain the truth. You don't have to explain that states actually do act in any real way. They don't. It's a theoretical notion. Pretending that they do is useful. When we're talking about the actions of states, it's useful for coming up with theories. It's useful for understanding the international system. It is not true, quote unquote. Okay, so just as theoretical notions are simplifications of reality that are not meant to be true, but are meant to be useful, the same goes for theories themselves. Theories are also not meant to be true. Realism is not meant to be an accurate reflection of reality. It's supposed to be a good explanation of how things work. Theories can only be overturned by a better theory. They can't be overturned by assertions that they are untrue, because they're also not meant to be true in the first place. So what is a better theory? Notice it's not a truer theory, it's a better theory, because there are at least two ways that a theory can be better. One is that it explains things better than the current theory. So when you view that theory, you understand things better. You can see how they happen. You can explain things. The other way is that it explains things more simply than the current theory, or both. So the more elegant a theory is, when scientists talk about an elegant theory, they mean something very simple. The idea of natural selection is extremely simple, and yet it explains all of the biodiversity we see in the entire planet. It's extremely powerful and very, very simple. That's the best type of theory. And realism is actually pretty simple too, and not quite as good as explaining things as evolution perhaps, but is also very useful. Okay, so theories in IR are useful. Well, any theory is useful because it departs from reality in all its complexity. So again, I've mentioned this before, the theory is not meant to be a completely accurate reflection of reality, because reality is too complicated to understand. If you included everything from reality in your theory, it would be completely useless, because it would be as complicated as reality. And we all know that we're having trouble understanding reality, which is why we're working on theory in the first place. So, abstraction is a good thing. A theory departing from reality is a good thing, as long as it remains useful. And you know how you judge the use of it: if it explains things well, if it works. basically, if you can explain outcomes with it. And if you can predict things as well. But you can predict things with a law too. We can see the patterns in the tides and then predict when tides will occur without understanding why tides happen. So a theory has to go beyond prediction, it has to explain. And the explanatory power is not related to how accurately, quote unquote, it reflects reality. Many IR theorists use the term theory in a much less precise manner. Don't do that. Be very, very careful. Be very specific in theory. It's important to understand it's an explanation. Alright, and this now brings us to a model. Now, what is a model? There are two ways of looking at it. One is a representation of a theory. Another is a simplified or reduced scale representation of reality, like a model airplane or a map. Although a map has a fair degree of abstraction, so it moves away from that a little bit. Models describe theories often visually. They're therefore distinct from reality and are not meant to be true reflections of it, once again. So theories are not reality, models are not reality, theoretical notions are not reality. None of them are meant to be quote-unquote true. They are all to be gauged on their explanatory power, how good they are, not on how true they are. All of these are related. These are all abstractions, models, theories, and theoretical notions. And see, say, page 7 about this. Also see the example of tides beginning on page 8. Alright, now I mentioned this a little bit already, how we reject a theory. Again, it's key to remember if truth is the question, then we're talking about a law rather than a theory. Right? So a law says a relationship exists. If we find that relationship does not exist, then we can reject the law. It doesn't reflect reality. If we find that we don't reach terminal velocity when we drop something, or the acceleration of an object in 1g of gravity is not what we say it should be, we can reject that law. It's simply not true. Okay, a theory is a little bit harder to reject. It can only be overthrown by a better theory. And when we have a good theory, we can see that other theories may fit the facts quite well as well. So then we could go with multiple different theories. That's quite a problem. And there could always be a theory that could come along that would fit the facts better than the one we have today. And at that point, we should reject today's theory and adopt the new one. We can never be sure. A theory can never be proven right, even if it's been around for ages. It can, however, be overthrown by a better theory. So once we have a better theory, we can reject an old theory as no longer good. For example, the theory of fire with phlogiston, I think, was what medieval people thought caused fires. The fire used up its phlogiston and then it went out. They didn't understand how combustion worked. When we came out with the theory of combustion, we saw that it fit the facts. It fit things much better. It explained things much better than phlogiston did. And so we rejected the theory of phlogiston and consider it to be untrue. But in fact, it just wasn't as good of a theory as the one we have today. I hope that makes sense. Waltz, in Chapter 1, Part 1, notes 4 ways that you can simplify something to arrive at a theory or a theoretical notion. I'm not going to go into that too much because I feel he explains it fairly well, but I also feel it's not really necessary to understand the entire book. It's something when you start getting into more theoretical thinking yourself, perhaps, and you're looking for inspiration or looking for possible approaches to thinking about something theoretically, you can come back to. I don't think it's that important now, so I'm just going to move on. Instead, let's talk about theoretical assumptions. Theories are combinations of descriptive and theoretical statements. The theoretical statements are non-factual. You see this on page 10. But you don't just come out with random theoretical statements. That's not the point. Just because it's not factual doesn't mean you can just come up with whatever you want. They're introduced only when they improve the theory's ability to explain. And they are judged by how useful the theory as a whole is. So you introduce such assumptions only insofar as they make the theory better. You don't just throw in random stuff, and you definitely don't throw in stuff that doesn't have any use and doesn't make things work better. Examples of non-factual assumptions are national interests and states as purposeful actors. Actually, I think states as purposeful actors, that's more of a theoretical notion. But the idea that states act in a national interest itself may be a theoretical notion, but an assumption is that the states will act according to their national interests. Another assumption is that states act according to their highest interest, and that their highest interest is survival. And I think he notes, I'm not sure if it's here, it may be elsewhere, that states may not do that in every case. They may value things even higher than their own survival. They may choose to eliminate themselves and join a federation. They may choose to give up sovereignty. That is a theoretical assumption that helps us explain things when we're looking at conflict and when we're looking at systemic factors. It doesn't mean that it's true all the time. It doesn't mean that it's a 100% reflection of reality. And we'll get to that a little bit more later. So don't ask me questions about the EU and pooled sovereignty until at least chapter 5 or 6, because I think some of that will, some aspects of realism will actually open the door to an explanation for how that can happen. You have states giving up sovereignty, and if state survival is the #1 thing, then you would think giving up sovereignty wouldn't make sense. Anyway, again, these things are useful, not real. Okay? Okay, Waltz also notes briefly when a systemic approach is needed, and he lays out a couple of questions. Can the thing you're studying be studied by isolating 2 variables and holding all the others constant? So you can get an x and a y variable. You can usually have that in a laboratory type situation, so that's very helpful. In international politics, obviously, it's really difficult to do that. We can't run laboratory experiments. Can you study it using statistics? For IR or politics, that's possible if you have enough cases to perform a reliably statistically significant analysis. If you only have a couple of cases, so you can't really use the statistical analysis, and you can't hold 2 things constant. And the final thing is you're studying something that is both complex and organized, then you need a systemic approach. Okay, so how should we judge theories? We've discussed several times that theories cannot be proved wrong or right, but page 13 tells us how we should judge how good they are. You can infer a hypothesis from a theory, and that means, according to this theory, y should happen when x is present. So you think about what the theory says, how it explains logically, and then you think of a law-like statement that you could derive from that. If x, then y. That's an auxiliary hypothesis, and as a law-like statement, it can be tested. So it is either true or false, unlike the theory itself. And be careful to note the other bits mentioned in the 7 steps when inferring and testing hypotheses. Okay, and here's an example of how we can infer a hypothesis. Let's say our theory is that plants use light to make sugar. And we know that to be true today, but it is in many ways, quote-unquote, just a theory. The hypothesis we could draw from that, the way we could test that, because it's very difficult to test if plants use light to make sugar, especially if we have only basic technology. So some theories may eventually become directly observable. But yeah, initially, when we come up with the idea, how do we test that? Well, a hypothesis we can draw from that theory is if deprived of light, the sugar content found within the plant structures will fall. That would give us strong evidence in support of our theory. You could also say one other hypothesis would be the plant will die without light, and that's it's easier to test, so maybe that would be a first stage, but the plant could be using light for things other than making sugar. So this one is more difficult, the hypothesis, more difficult to test, but it would give us better evidence towards our theory that plants use light to make sugar. And this highlights the need to think carefully when you're inferring and testing hypotheses. Is it really going to test the thing that you want it to test? Okay, and as pages 14 and 15 say, perhaps the #1 problem that people run into, and I mean everyone, is the lack of clearly defined variables. What do we mean by instability? Waltz talks about authors using the term instability, and they all mean, they seem to mean different things by that. Are they talking about the stability of the system? And he points out that a system could be stable if it survives wars. But many of the authors seem to equate instability with war. So it's not about whether the system survives, it's about whether the system produces war. Well, if that's what instability is, why not just call it war? And then, of course, you run into the problem of how do you define war? Is it conflict? Is there a difference between war and conflict? When is conflict war? What is a confrontation, etc.? On the other hand, if instability isn't war, well, then what is it? What exactly do we mean by stability and instability? We can't infer a hypothesis from a theory, and therefore we can't judge a theory if we don't know what we're talking about. And it sounds like common sense, but getting a clear definition of ideas is harder than you probably imagine. And people come across it all the time. I've read loads of things about terrorism, for example, and the conclusions that people come to are sort of convoluted or confusing, or they're not able to come to any solid conclusions. And I see that the problem is that they never really define terrorism properly. They're not sure exactly what it is that they're trying to talk about. And this, by the way, happens to me all the time as well, so I'm not just pointing the finger at others. I have worked on something for a long time and then come to realize that actually I have no idea what I'm talking about. It sounds ridiculous. It sounds like a total rookie mistake, but believe me, it's an expert mistake. It's a mistake that people make all the time. What exactly do you mean when you say stability? What does war mean? It sounds like, well, what do you mean, what does war mean? Everybody knows what war is. Do they? What do you mean when you say war? And I hope you can understand how you can't come up with a theory about something or explain something if you don't know what you're talking about. It's crucial. And Waltz will get a little bit more into that as time goes on in the book as well. Okay, we're nearing the end. 2 more slides to go. Okay, so we've talked about judging theories, we've talked about how to derive an auxiliary hypothesis from a theory which can be tested directly, because the theory itself cannot be tested directly. Right? If we're thinking about realism, if you know what realism is, we're getting to that, of course, but you can't test realism directly. But realism gives explanations for things, and you can draw a hypothesis from that. You'd say, well, if that's true, then this should happen, and then you can test that hypothesis. But those tests alone will not be enough. They can't tell you whether you should discard the theory altogether if they don't hold up, or if the theory needs to be amended, or maybe its scope needs to be limited. Maybe it can't tell you about all the things that you initially thought it could, or maybe the theory seems perfect and you don't need to change anything. But you won't know that without further thought. And if we go back to that photosynthesis example, if sugar amounts declined in most of the plants that you deprived of light, but not all of them, we have a bit of a problem. That's not what we were expecting to find. Does that mean the theory of photosynthesis is wrong? Or is something else going on? One possibility is that plants need light in an indirect way, so photosynthesis could be kind of wrong, or it would need to be amended. Another way is that maybe some plants go dormant and can hold on to sugar when deprived of light, so the plant just goes to sleep and doesn't use up its sugar because it recognizes there isn't any light. Now, I don't think any plants on Earth do that. Well, trees, in a way, they lose their leaves. So many trees lose their leaves and go dormant during the winter, but I bet you'd see their sugar levels falling because they still need them. We won't know the answer. We won't know how to judge the theory until we investigate further, and that's what science is. So just finding a result that doesn't go along with the theory doesn't mean it's wrong. If we find lots of results that go along with it, but some that don't, then theory sounds pretty good, but what about those examples where it doesn't go along? If the cases where the hypothesis comes up as untrue are really typical, where the theory strongly suggests they should work, then we need to have a good look at the theory. If there are lots of other confounding variables here and lots of other things going on, and it's sort of a weak area for the theory anyway, then we might limit the scope and say, all right, in such a situation, this theory isn't so useful, but it's more useful in these other areas. All right, if you've gotten this far, congratulations. Part 3 of Chapter 1 is the conclusion. Chapters 1 and 2, by the way, I think are the most difficult chapters in the book. So you're halfway through the most difficult parts. After that, it starts to get a bit easier. This was the most theoretical and abstract part, and we get into some more specific stuff later on. It gets progressively less theoretical, although it is a theoretical work overall. So to sum things up, you need a theory in order to decide what to concentrate on. You need an explanation before you can figure out what all of these events means and what the patterns that you're seeing mean. And this is a good quote of his. To proceed by looking for associations without at least some glimmering of a theory is like shooting a gun in the general direction of an invisible target. Not only would much ammunition be used up before hitting it, but also, if the bullseye were hit, no one would know it, because the target's invisible. The next chapters will rip current reductionist and systemic theories to shreds to clear the ground for his proposal. And these were current in Waltz's time, so it's going to feel a bit weird talking about these things because they're not theories that you hear a lot about. He spends a lot of time ripping stuff apart that most of us are already convinced of is not true. But the reason we're convinced it's not true is because Waltz told us, and Waltz convinced people over time, and his theory still stands. The way that he goes about this will help you think a lot more critically about others' work and your own, so it'll help you read better, judging others' work, and it will help you write better, using that critical eye, which means you'll get much better grades. Honestly, this will really help you. You'll see how he's absolutely vicious and tearing things apart, but completely correct. Very careful, analytical, and logical, and this is the type of approach that you all should strive for, I think, personally. It's something that I strive for. I have not achieved it by any means, but it's definitely a goal, and you'll see it. And it will feel academic and sort of relaxed, but I hope you'll notice that he's being absolutely vicious with his attacks. Absolutely relentless. Relentless is perhaps the word. So I look forward to that. Post any questions that you have about this on the Facebook page or on the YouTube page or on the event page on Facebook perhaps, but they may expire after the event actually. So the Facebook page for this course or the YouTube page are the best places to post questions. Please don't email me because there are some people out there watching this who don't have my email. I would like everything to be public. Everything that I receive by Sunday, I will try to respond to at the beginning of the next video to make this a little bit more interactive. So if you have questions going forward about the book, about the first chapter of the book, not any others, I will try to answer them before starting the lecture or seminar about the next chapter. And again, if this chapter seemed very difficult, don't panic too much. The book is difficult, but this is the most difficult chapter. The next chapter is pretty tricky too, and then I find they get a little bit easier. You also get used to Waltz over time, and so that starts to get a little bit better. Thanks a lot for joining me. I hope I didn't bore you. I had all these ideas about how I was going to put animations in and cool things like that to keep it interesting, and it turned out to be a slideshow. I don't know how to do animations. If any of you would like to volunteer to help out with that, I would definitely be on board. So I recognize that slides aren't particularly exciting, but I've tried to keep it relatively short, even though it's very dense. I think this will be the longest slideshow for the whole book because it's the hardest chapter, and I've really had to go through it bit by bit, page by page. All right, I'll talk to you guys next week. I look forward to your comments. Thanks a lot. See you later.